Do it's Chemdork.
Hello everyone, this is Chemdork, and welcome to episode number 60 of season number 2 of my Buildcraft, where we play Minecraft with the mods Buildcraft, Thermal Expansion, and Forestry. Well guys, we made it to 60 in season number 2. You might recall that season number 1 only went to 40 before we actually ended it, but 60 for season number 2 here. So where are we? Well, we are at Chemdork Gardens. This is the little log cabin at Chemdork Gardens. You might remember this from a little while back. It's been a while since I've been here and been around here, but it's quite a nice area. Lots of butterflies because we have lots of forestry trees here because kind of the purpose of Chemdork Gardens was almost to be a museum or something along those lines. Just to showcase the forestry trees. So we have, let's see, I don't even remember a lot of these names. I think this is the kapok tree, which is pretty cool. I like it. It gives you some nice green wood. Yeah, it does. As far as I remember, I don't recall. I think that's the blue maho over there. I think that's a walnut. That's a birch or something? No, it's not birch. It's balsa. That's balsa. Sequoia. I think these are like the fruit tree things. So I think that's plum. This is lemon. This is something, and that's papaya, and this is cherry. Yeah. Anyways. But anyway, we're going to be today continuing what we started in episode number 59. Now, in episode 59, we put in some double doors, double doors. We put in two of them. One with classic redstone, and the second one with Buildcraft, pipe wire, and pipe gates in place of the redstone. And then we took it a step further, and I showed you how you can make some simple redstone circuits using only Buildcraft, pipe wire, and pipe gates. Pretty cool. So in this episode, we're going to be continuing along that line. We're putting up in the main base, which is way over there, we're putting up some sliding doors, and I'm going to need a T flip-flop, and we're going to be using pipe gates, pipe wire, and just a little bit of redstone in order to fit that in a very compact spot. But before we get to that, I'm decided it's time to talk about these things down here. These are backpacks, and they come from the forestry mod. I haven't actually talked about this, but some people have been asking in the comments, Chemdork, why does this happen? So if I change this right here, why does this happen? So when I have 64 blocks of dirt and I'm building things, you see it goes away, but I still have 64 blocks of dirt. How does that happen? It looks like I'm cheating. Well, I'm not cheating. It's a factor, and it's a result of having these backpacks. And these are a really cool feature of the forestry mod. So if I right click, it opens up the backpack, which has an inventory all its own, and you see it's a pretty large inventory. It's 45 slots. These backpacks come in the woven variety, which has 45 slots, and the non-woven variety, just to show you kind of what you can do. For the forestry mod, there are tons of backpacks available. You notice they have different names. There's Forester's backpack, there's Digger's backpack, Miner's backpack, and they all serve to hold a different type of item. So Miner's backpacks, for example, hold things like ores. And you notice the small one is 15 slots. The big one, with the gold little button, is 45 slots. And so they hold ores and things you get when mining. Digger's backpacks, which I have right here, hold things like cobblestone and dirt and gravel. The thing right next to it is a builder's backpack. It holds things like stone and stone slabs and glass and things that you can kind of like make with stone bricks and things like that. So what do these things do other than giving you just an inventory? Well, you saw one feature, which is when you shift right click, they go in between different modes. With the yellow arrow, they're kind of in what's called a resupply mode. So I have some dirt here. If I place a block, you'll see I had 64 and 15 blocks of dirt. Now it's 63 and 15. So you see it took a block of dirt from this inventory, added it back here. It'll resupply any space that has some dirt. So I can put things in it, just that'll fit. Red wool shouldn't fit in here because it's a digger's backpack, and you see I can't place it in here. So it only can fit the specific items that it's supposed to be able to fit. But if I do things like split my dirt pack, if I place this, it's going to be 32 blocks, and then immediately it fills it up again with some blocks. If I throw them on the ground like that, actually I'll do it this way, yeah. If I throw them on the ground like that, run over them, it picks them up and puts them straight into the backpack. So Here, I'll do it this way. 64, 64, and 14. If you notice when I step over these, now there's an extra stack. Pretty cool. So if I just turn into normal mode, it doesn't resupply anymore. And I should note that if I grab blocks, it'll still fill the inventory slot until it's all full, and then the last one that I can't have room for, normally in Minecraft it would go into one of these slots, but when you have a backpack with a normal mode, 64, 64, 64, 14, I'll step onto it and you'll see now it went right into here. Then there's the locked mode. The locked mode, well, basically allows you to, let's see, if I toss the blocks out here, you'll see that those 8 blocks, I think that's what it is. Yeah, they went right into my inventory. They don't go into the backpack. You can, however, just place them there yourself if you want. And then the final mode is this little up arrow. I'm going to show you that over here. This is another little feature that's pretty cool with these backpacks. This chest is empty, as you see. I have some items in here. I have actually 12. So if I shift right-click on the chest, nothing happens. I'm actually going to go into this resupply mode. If you shift right-click in resupply mode onto a chest, all the blocks from this backpack go into the chest as long as there's room. If I shift right-click again, nothing happens. But if I shift right-click when I'm in the green arrow mode, which is the receive mode, yeah, I think so, and you have a chest with things in it, if I shift right-click, it'll grab those items out of the chest and go right into the backpack. So really, really useful. And I should note that, again, the backpack can only hold the specific things it can hold. So the builder's backpack can't hold everything in here. There's not enough room for one, but there's also some types that aren't able to be held in the builder's backpack. So if I say resupply mode, receive mode, do the shift right click, it only took a few of these types of items, and it only took enough that it could, it didn't even fill this backpack, because some of these items like oak saplings don't go in the builder's backpack. And again, I can put them back by going into resupply mode and shift right clicking. Yeah, there you go. So everything's back where it was. Cool. All right, so that's a little bit about backpacks. Just decided to discuss them because we never have before. Now it is on to talking about the double sliding doors, and we're going to be building today in episode number 60. So let's make our way to the main base here. Let's take the minecart because this is the cool system. I definitely like this minecart station. Very awesome. Okay, so see you there. So we're here again. This is the main base and the second floor. This is kind of what we started last episode, just to illustrate what we're going to be doing here. So I want to put in 2 double doors. This is not the full setup, obviously, but it includes all the working bits and pieces, and it allows me to move around. So I'll put in everything later, but for now, the idea is that if I step on these pressure plates, it opens up these double doors, as well as the ones across the way. And then when I go into this area right here, I can either go straight across, step on those pressure plates right here, that closes both double doors once again. Or I could have gone, if I wanted to go up this way, what I would do is push this button, which closes the doors, and then I'll just go up here. And likewise, if I go into this area with the doors closed, I push this button to open both doors, and then as I pass either over these pressure plates or these pressure plates, the doors will close behind me. Now, this type of functionality, what I want is really the functionality of what's called a T flip-flop or an edge-triggered T flip-flop circuit. And that's what we are going to be building today out of pipe wire, pipe gates, and just a bit of redstone. The functionality of one of those is, as you'll see, I think what we need to do is, of course, do what we usually do, which is to go to the creative world, where I can describe a little bit about the circuit and then how to build it with classic redstone, and then how we're going to build it with the pipe wire and pipe gates that we kind of worked on last episode. And yes, as you might recall, the T flip-flop circuit does include, inside the circuit itself, basically an RS NOR latch. So yay, we're still doing RS NOR. My favorite circuit. Okay, let's get to the creative world, and I'll see you there. Well, here we are once again in the creative world to talk about some redstone. It's one of my favorite subjects because I love doing this stuff in Minecraft, because redstone allows you to do a whole bunch of stuff. It allows you to make Minecraft a bit more functional rather than just a bunch of static blocks hanging around, which is nice to look at, kind of fun to play in, but then it gets old after a while, right? So making things move and do things for you is what makes Minecraft fun for me. So, the main way in which I make things move and do what I want is, or has been, the RS NOR latch, which in last episode we demonstrated this is an RS NOR latch, this is also an RS NOR latch, and we indicated that it's basically made of two compound logic gates called NOR gates. So this is a NOR gate, and this is another NOR gate. Together they make up the RS NOR latch, where the output of one is supplying as one of the inputs of the other. And then the other, it has another input as well. And NOR gates themselves are made up of really simple gates as well, called an OR gate, which is this, effectively, and a NOT gate, which is effectively this little thing here. It's just an inverter. So combined, they are a NOR gate. How nice. And then what we did is we showed that in these cases, you see the gates themselves are actually 2 blocks tall because you have to have room for the redstone on top. And they can be pretty compact, quite compact right here. This is a little more expanded version of one. But when we switch to Buildcraft pipes and pipe wire, we can make them 1 block large in total. So the only thing doing RS NOR in this case is this right here, this diamond OR gate, which is set to not. The NOT of the inputs equals, if it's true, then the output is this, and then, yeah. So there you go. That's the logic behind it. We're not going to go over that specifically how to do it again, but that's what we talked about last episode in a nutshell. In this episode, we are going to be putting together a T flip-flop. Now, a T flip-flop, what it's going to allow us to do is, if you notice this RS NOR, we can switch between 2 different states. So we can switch between, say, this one being on and that one being on. But in order to do so, we actually have to switch where we supply the power. So in order to switch it back over here, I have to supply power over here. And in order to switch it back over here, I have to supply power over here. The question is, can we just do that by having one single lever that anytime we push it, or a button that anytime we push it, or in our case a pressure plate as well, anytime we push it just toggles between this state and that state. And that's what a T flip-flop is going to allow us to do. And we're going to need it to be edge triggered, which is something else we'll have to go into in a little bit. But first, before we put all this together, I had mentioned that the T flip-flop includes an RS NOR in its core design, and that is because, as I just indicated, it's actually switching between 2 states, just like an RS NOR. So let's go ahead and build one. So as we start to build our T flip-flop, we're just going to start off in normal redstone, and then I'm going to show you how we're going to turn this normal redstone into a mostly pipe wire and pipe gate version. So this is an RS NOR, and I'm just going to, for the illustrative purposes, supply, let's see, I'm going to supply a little bit of height to this so we can see the signals. So we're going to look and switch between the 2 states of this lamp being on and that lamp being on. I need some height just so, because you'll see in a second. Now the other core gate that is included with a T flip-flop is another simple gate we haven't talked about before, and it's called an AND gate. We've talked about some AND gates before, but it's worthwhile to actually discuss what is an AND gate. An AND gate has, well, can have multiple outputs, but in this case, we'll do a simple AND gate, 1 output and 2 input lines. You can have more than 2 input lines, but in this case, we have 2. Get over it. The AND gate is pretty simple. It's displaying AND logic, and you probably can kind of figure out by now, AND logic is indicating that if you have 2 inputs, the output is off unless not one, not the other, but both of these inputs are on. That's the only time when the output is true, is when both inputs are on. If either one or both of the outputs are off, or inputs are off, I should say, the output is also off. So that is what an AND gate is. And actually what it turns out is that the T flip-flop includes 2 AND gates in addition to the standard RS NOR, which includes the NOR gates. So I'm just going to start to build the AND gates in, and then I'll kind of explain as I build it or after I build it maybe, how we're going to connect them and how they're connected in the T flip-flop circuit. So this is an expanded design of a T flip-flop, not the most efficient at a standard redstone, but that's okay. So one side of the AND gate for both of these is going to be our combined line, which is the sort of combined input line. This is our master input. This is where we supply a signal. And every time I do this, I want it to switch from wherever state it is to the other state. Right now it does nothing because it's just one input. Remember, in order for these torches to come on, which are the output of those AND gates, we actually have to have both of these torches off, meaning that we have to have a supply current over here and the current on the other side. Or, yeah, over on this side and on that side. So the other side is just going to be, I'm going to set the nearest RS side of the RS NOR latch to that as an input. And so you'll notice that when I give a signal here, this one comes on because both inputs are on. This one stays off because only one of the inputs is on. Okay? And now the outputs of these AND gates actually need to be set to the opposite side of the RS NOR latch. So whereas this AND gate is getting an input from the right side, if you will, of this RS NOR, the output needs to go to the left side. And likewise, this one's getting an input from the left side, and output needs to go to the right side. So I'm going to do that like this. Yes, I'm going to do it like that. Okay, so in this case, the output here is going to the right side of the RS NOR, and yes, this counts as the right side. The output of this guy needs to kind of cross over, so we're actually just gonna, yeah, I'm just gonna literally cross over, right, just like this. That'll do it. Yeah, that should do it. Okay, so, whoa, no it won't, no it won't. We gotta stick a block right there just for fun. Okay. So it's not pretty, but it works. It is going the right way as it should. So this output is the left side. It is hooked up to, or yeah, okay. I'll keep my sides correct here. The left side of this RS NOR is hooked up as one of the inputs is going to be the right side AND gate. Okay, so now when we supply a signal, it switches. It switches. There you go. That's the functionality of a T flip-flop. Two AND gates that are kind of swapped in terms of their outputs and inputs. And one of the inputs of the AND gate is the toggle input here. Now, what happens when I leave this on? This is the reason why I need it to be edge triggered. Okay, it burned out the torches. But what you see is that if you leave the toggle input signal on, it just alternates between the two forever and ever and ever and ever. So in order to make this work reasonably, and give me a minute, I actually have to replace all the torches now because one of them burned out and I don't know which one. Well, let's see. No, it seemed to be okay. Okay, so yeah, let's build in this to only fire when I give it a signal. And in order to do that, that's where we need what's called an edge trigger. And we've built one of these before. Suffice it to say, I'm not going to go into the simple circuits that go into an edge trigger. Maybe I'll leave that as a homework assignment for you guys to say, hey, what are the simple circuits that go into an edge trigger? So let's build an edge trigger here. Let's see if I always have to kind of feel this out. I think this is, yeah. So the edge trigger has a delay of some sort usually, and this is going to be our input over here. And then one side is delayed, the other side is not delayed, and that should be it. Yeah, that should do it. I just want to see if this actually works. So it's on at this point. Oh, no. I'm missing, oh, yeah, that's right. One side's inverted. That's right. Okay. Yeah, this is right. For sure, I know it's right. I'm just going to actually connect it. Okay, so every time I do this, it'll send out a pulse. Oh, wait. There we go. Every time I give it a switch. And now you see, I can leave it on and it doesn't alternate between the two. It's just sending a pulse through the circuit. So if you guys don't understand what's going on, watch this as the output of the edge trigger. It only goes on when I turn this input line from off to on. You see it pulsed once. That's what the edge trigger is doing. It's giving us a pulse. There you go. Cool. Okay, so now that we've discovered how to build an edge-triggered T flip-flop circuit, let's talk about how to build this now using pipe wires and pipe gates to make it a lot smaller. Okay, see you in a second. So now it's time to translate what we did over here with this edge-triggered T flip-flop into something with pipe gates and pipe wire. So just finishing up here, this will be our toggle signal, which will be the red line right here. That'll be our toggle signal. And then one of the sides will be the RS NOR, basically within here, is going to be the blue wire, and the other signal is it's hard to see, but it's a green wire. Okay, so let's actually make it a little easier on ourselves. I'll try to be as clear as possible here so you guys can follow along. I'm going to use wool to mark what we're doing over here to match what we're doing over here. Each of these colors of wool is going to be representing a different pipe wire color. So, like I said, green we'll put on the right, so we'll just stick a piece of wool right there. It represents this line, which is this side of the RS NOR. And recall, this is the RS NOR. The other one is going to be blue, and that's the other side. And then the toggle is red. And now this leaves us with yellow, and, well, that's it, right? But we have two other signals we need to mark. We need to mark this line right here that's on right now. It's the output of this AND gate over on the right. And we also have the output of the other AND gate on the right. So let's just mark this one. But what's this other output going to be? We're out of wires, right? Well, we're actually just going to use redstone to talk to the gates. So one gate is going to have an output of redstone, and another gate is going to have an input of, well, redstone. What that means, though, however, is that we can't use these gates and make it simple. We actually, because you well, here, I'll just put it here. Because you cannot specify redstone and a pipe wire condition to be true on the same line here, we have to use multiple gates. So we're going to use an emerald OR gate, and this is going to represent our two AND gates. So let's go ahead and set those up right away, because the emerald OR gate will have two lines. One line is going to be for this AND gate, and the other line is going to be the logic implied in this AND gate. So let's go this AND gate first. So this AND gate has an output, which is redstone, and that will be true if both the blue signal, which is coming from this side of the RS NOR, is on, as well as the toggle signal, which is this red signal, is on. So if red and blue are true, then we output a redstone signal. So let's go ahead and set that up. So it's red and blue, and I put all the wires here just to make it a little quicker for us all. Even one little yellow wire right here, you'll notice. And then the other AND gate is going to be if red and green is true, then yellow. So we'll set that one up too. That's going to be the second line. So if red and green, then yellow. Okay, cool. And then these two emerald AND gates are going to be our two RS NOR latches. So, or I'm sorry, our two NOR gates from the RS NOR portion. Now, the way to think about the RS NOR portion is that if one side is on only if the inputs on the other side are off. That's the way the NOR logic works. So if both inputs are off on the other side, the one side is going to be on. So if you look, let me actually just go. Let me actually switch this RS NOR for a second. It's easier to demonstrate in the other state. So wait, actually, I need to get a long enough pulse. Come on, there you go. Yeah, okay, that's what I wanted. Okay, so the green side is now on. In order for green to be turned on, we have to have off the blue. And we also have to have off this line, which is yellow. So if blue and yellow are off, we're going to output green. Okay. So that makes sense? Yeah. Yes. If blue and yellow are off, we output green. So we'll put that on top. Yellow off and blue off, output green. There we go. Okay, and the other one is going to be, let's switch it again, just so we have blue on so we can see what's off. There we go. if blue is on, that means green is off, as well as, and this one goes underneath, it's as redstone is off. So if redstone is off and green is off, then blue is on. So if redstone is off and, what did I say? Green is off, right? Green is off. And green is off, then blue is on, right? So blue is on, blue is on. Hey, just a minute. There we go. Okay, good. Okay, so let's see what test if this works. Okay, that actually does work. If you notice, that's what it's supposed to do when we leave the signal on. What we're missing here is the edge trigger. And so let's build in the edge trigger. For that, we need some redstone. Unfortunately, we can't do this all with redstone without redstone. So we'll actually, okay, I'm going to take away that. There we go. And we're going to build a little edge trigger here. Now the edge trigger is made up of two signals, and one signal is the opposite of the other one. And when they both arrive, and one signal is also delayed. And when they both arrive at the sort of end point, then it's true, and it sends out a signal. We'll kind of actually look at this edge trigger right here. So it's sending out actually two signals. One signal is delayed, and it's redstone on. And when I change this from off to on, this signal changes from off to on. And then in the opposite fashion, we have a not signal of that is not delayed. That's also arriving here at the same block. So they're both arriving at the same block. In one case, it's easier to see when it's this way. In one case, a signal is sent that's opposite the other signal, which is delayed. So you'll kind of see what I'm going to do here. The one delayed signal is going to be a redstone signal. It's going to be right here. We're going to delay it just by a repeater. And in fact, yeah, let's just do that. And then the other signal is just going to be straight up. If redstone is on, send a... I got to do this all over again. Wait. Send the blue pipe signal. Okay. And then here, it's going to be, the output is going to be a red pipe signal, but that's only going to be true when you get a blue pipe signal and a redstone signal that, that's on from that gate side only. Okay, that's working. Okay, so this should work. Actually, what we need to do is, oh, I'm sorry, this should be the opposite. There you go. Okay, it's when it doesn't receive a redstone signal. Okay. Okay, it's not putting out a signal because this isn't delayed enough. When we delay it a little more, and now it puts out the signal. And now every time we pulse this, you notice that our RT flip-flop is flip-flopping. Pretty cool. All right, so that's how we're going to do it. That's how we're going to build it in the piston gate system. We are going to use some redstone, like I said, but mostly pipe gates and pipe wires. And notice this is still 1 block tall, which is very important for our design because we don't have much room underneath the floor. Okay, that's about it. I'll be right back. Now hold on just a minute. There's one more thing to show you that is a bug or a consequence of the way gates work. This was a little bit confusing for me. It took me a while to actually figure out what was going on, but basically we have our RT flip-flop, which is working perfectly. This is exactly how it should work. No problems. This is exactly the same thing represented that we built here. It's exactly the same. I actually used the gate copier to great effect to copy all the gates over. The only difference is that this gate and that gate are swapped positions. So this is now on the what is the north side instead of the south side. And let's see what happens. Okay. The gate doesn't like to switch, or it kind of alternates in a funny way if you don't have the positioning of these gates just so. It seems that the most important thing is, and I've tried different permutations of this, at least in this fashion, but basically what we need is the OR gate needs to be on the south side for whatever reason, and when it is, everything is fine. No problems. And it doesn't matter if it's oriented. I don't know what happens if it's oriented in the north-south direction. So We'll actually just try to build that into our gate system, and I think we'll be fine. But still, that's just a really confusing thing. It doesn't have to be an emerald gate. We can use a diamond gate in this case, which is what we will do. Okay, so just wanted to share that with you. It's a bit of a funny thing that is going on with this. Don't really know why. I think it has to do with basically when the update timing is for these gates and like what gets updated first. And that does matter to some extent here because it switches so quickly. Okay, I'll be right back, and we'll start building. Okay, well, here we are back at our little location. I've started to run the input lines now. I'm just putting the gates. I'm going to put them on top of the pipe. You don't have to, but basically, I wanted to run red. We're going to change our initial input signal to red, and then it's going to switch over to blue. Or, I'm sorry, yeah, it's going to switch over to blue, and I'll have to do some switching around, but it should be fine. So anyway, the redstone signal on is going to send out a redstone signal and or a red pipe wire signal, and I'll just set that to be true here for all of these inputs because all of these inputs are triggers. I want the gate to be there because it's out of sight at least. It's not unsightly, so there we go. And that means that when we do this, we send a signal, and the same way when we step on these pressure plates, the same thing, right? So, and I'll do the same thing over here, and then I'll start to set up the pipe wires and pipe gates for doing the well, let's see, yeah, for doing the edge trigger. Okay, I'll be right back. Okay, the first step in this is to set up the edge trigger. So we're going to work from the farthest away from that RS NOR portion of this T flip-flop. I think I'm going to use, well, okay, the orientation, first of all, being north and south. North is that way, south is this way, so I'm going to have the pipe wire, basically the pipe going this way to adjust our edge trigger. And I'll try to have the RS nor the gates not be over top of that, because what'll happen is it'll mess around with the status of this of course. In fact, I'll try to have it here if I can, or somewhere else, maybe like over here. Yeah, that's actually probably fine. All right, so let's see what we can do here. All right, so maybe we put this asymmetrical. That's fine. I think what I need to do is yeah, let's just do it this way. So this will be where we set up if there's a red pipe signal, send a redstone signal. Okay, so we'll set the redstone signal here. We'll then set a delay. We'll do that type of delay just like we did before, and right just like that. And then on the flip side, there's going to be a red pipe wire here. And then the actual toggle input for our T flip-flop is actually going to be blue in this case. So I'll need it to happen right here. And the reason why I'm putting this offset, again, is to just so not to interfere with that. So there we go. Okay, and then I think we can just use, yeah, we can use an iron AND gate because this can communicate with blue. So AND has to be true. It has to have a redstone signal being off at the same time it gets the red pipe signal on. And that means it'll send out a blue pipe signal. So we should be able to test this to see what'll happen. It should send out a pulsed blue. There it goes, a little quick blue pulse. That's all we need. Okay, same way we do it. Let's see if I can do it here. Yeah, I saw the blue. I don't know if you guys did. Yeah, there it is. Okay, so good. It seems to be working fine. It seems to be working like it should. And now here is where we set up the business of the AND gates and whatnot. So we want the diamond OR gate, remember, to be on the south side. Come on, grab it. On the south side, which is that way. So let's place it there. And then the other sides are just going to be diamond AND gates, and diamond's just going to be fine for this. So this is the core of everything. So with this, we need to make sure we place on there green and yellow and also red. Yeah, so we need green, yellow, red, and redstone is going to be the other one. Let me just give me 1 second to figure out the logic behind this now that I switched from blue. From red, this line used to be red in our creative world, and now it's blue. Give me 1 minute. I'll be right back. Okay, I figured out the logic, and I actually had to figure out that we need to make sure that the signal that goes off, which is the signal that is on by default, is not red. You'll kind of see what I mean, and the reason why it can't be red is because we're actually going to have it running along a lot of this same the same cobblestone structural pipe. So let's start with this diamond ore gate, and we're gonna indicate the logic of the two AND gates that are a part of this T flip-flop. So the input line is now blue in this case instead of red as it was in the creative world. And the one, come on blue, there you go. Okay, the one is going to be if it's blue and green, then a redstone signal. If it's blue and red, come on red, then it's going to be yellow. Okay. Up on the top, we're going to do a no redstone signal, and if it has no redstone signal, but it's getting a no red pipe wire signal, then it's going to put out a green signal. Okay, and then this which is going to be the on by default line, and then this is going to be if it's not getting a yellow signal. Come on, not yellow. And not green, which is not true right now, then it'll be red. Okay, so this should switch. We should see the red come on. We should see it alternating between green and red, actually. We're at the problem. Okay, we probably need to adjust the position of these gates. I'll be right back. Okay, guys, well, we have a problem. Remember in the creative world where we were messing around and we actually found a solution to gates that would alternate really quickly back and forth, and we could just kind of reposition the gates, which I just tried. I tried all sorts of permutations of placing the AND diamond gate and the two OR diamond gates in different places onto the sides of different sides of the pipe, and to no avail. Basically, no situation could fix the fact that we had just the two different states switched too quickly, so that even no matter what the length of pulse, it's not short enough to just switch once. And at least not in a reliable fashion. So, with that in mind, let's force this to be a little slower. And it's a little less efficient this way, but this should work. And that is what we will do is have to separate all of the. It'll work. It'll be a little less efficient in terms of number of gates, but it'll work just the same. So this should, in theory, work. So what I'm doing here is I'm going to be delaying the signal from those two AND gates to go to the two NOR gates, and we're just going to delay them right here. So in fact, this redstone delay might be absolutely sufficient. So what we'll do is as follows. We're going to have a basically what we need. Let's get rid of that. Okay, so basically what we need is this sort of setup. It looks a little strange, and that's because it is. But basically what we have is this is the toggle signal. So this is the signal coming in. This is the same pulse sequence, just a little different positioning. But similarly, when it's a pulse detector, so it's an edge trigger. It's going to send out a blue pulse whenever we step on this thing right here. You see the blue signal pulses really quickly for a while, right? Okay, so we learned how to do that in the creative world just a moment ago. The two AND gates are going to be here and here, and I'm going to set them up with blue on one side and green on the other side, and blue and yellow on the other side. So blue, red, green. Yeah, let's do it this way. So this should actually be enough, and this will be with the blue and green side, and I'm going to run this green wire way down here. I actually have to run it all the way across here, at least. And the yellow, similarly, has to be run all the way here. And this is blue and yellow, in which case I need a diamond AND gate. All right, so here we go. Boom. Okay, so the diamond AND gate doesn't technically need to be an AND gate. The AND gate is here. Blue on and yellow on, and we're going to send out a redstone signal. And over here, it's going to be blue on and green on, and we send out a redstone signal. Okay, so there are your two AND gates as part of the T flip-flop. The other part of the T flip-flop is over here. One that's receiving, that's looking at, they're actually going to be, it's going to be a diamond. Yeah, they need to be diamond AND gates. These two need to be diamond AND gates. So the diamond AND gates have the one over here by the, well, actually, it doesn't really matter which is which, but let's just say this one will be the signal that when it's receiving no redstone signal and it's receiving no yellow signal, then we're going to have from the side of the gate only. Why not? Right? Let's actually set. No, that's fine. Don't worry about it. Yeah, don't worry about it. Let's actually set this to go green signal. Green signal. Okay. And likewise, this is going to be very similar. When it's no redstone signal and it's receiving no green pipe wire signal, it's going to be putting out a yellow signal. Now, this should work. Okay, so this should work. We should see it. Okay, there we go. Perfect. Ah, huzzah. There we go. Nice. And in fact, we can even delay it just slightly just to make sure we're all happy. It should still be okay. Yeah. Oh, that's perfect. Okay, that's how we're doing it. Okay, so now the question is, one of those states is going to be on where these are extended, and one is going to be where they're not extended. Since I actually have a lot more diamond than gold in this case, I'm actually going to make the yellow. Well, actually, it doesn't matter. It doesn't really matter. So in this case, I'll just put some, whichever gates I have more of, I'm just going to alternate them. So what we need is, we don't need to actually have both of these activate. We just need to activate this block right here. And then when this gets a, you know, it doesn't really matter what the signal is. I guess we'll use, what do we have a lot of? I think we have a lot of green because of the cactus. Yes, we'll do that. Okay, so now we just have to run this green line everywhere. Okay, there we go. It's over there. And now when this says, when it's receiving a green pipe signal, redstone. Okay. There we go. Okay. That's what I want to talk about. Okay, so now I'm going to hook up all the pistons to that green line. Be right back. Okay, check it out. Ta-da! Nice. Okay, so and we also works if you push the buttons. Cool. So we fixed it. We fixed it. It works now. And this is a little more reliable of a T flip-flop. It's kind of this whole thing right here. This is pretty important because you have to delay those AND gate signals. You can get it to work in a even more efficiently well-packed manner with less gates, but it appears to be a little bit tricky and a little bit finicky. So this is a little better of a way to do it. You need the pulsed edge trigger if you want it to stop from just going back and forth and back and forth and back and forth. Maybe we can demonstrate that right now, just in case you all might be saying, but ChemDork, what? I don't understand it really. So here, let's say if we get a redstone signal, do a blue pipe signal, and just stick a piece of torch here. Yeah, that's what'll happen. So instead of doing that, so we have to send a... what we want is always to send that. Just a little pulse. Okay, so let me fix this up. Let me actually put in the floor again and make it look a little prettier, and I'll be right back. Okay, well, here it is. So the double doors are set. So if I want to go out, I go out. Otherwise, I just go straight on through, and they close behind me. So if I just want to go straight through to the beekeeping area, there you go. That's what I do. Otherwise, yeah, I do have to do this, but we can change that later. The other way is if I'm coming in here, yeah, I can push the button, and good to go. There is a little bit of a lag, though, so maybe... Yeah, actually, you know what I'm going to do? I'm going to change this into a a stone button, it'll be a little bit quicker. Because the stone button has a little bit of a quicker... yeah, so there it is. There you go. Okay, you just have to kind of go not too fast through it, but that's okay. We can adjust that a little later. But anyways, guys, this has been a long episode, but a productive and fruitful one. We learned a little bit about, well, how to make a edge-triggered T flip-flop in with Buildcraft pipes and pipe wire and a little bit of redstone. So it's an edge-triggered T flip-flop switch, which has saved the day for us and made this possible in that small area underneath. And it's only 1 block high, the entire setup, which is pretty cool for redstone and very difficult to do for those T flip-flop type of situations. Okay, guys, well, thank you for watching, and I will see you in the next episode. Take care, and see you later. Bye-bye.